Okay, so on this section, we're solving radical equations, and basically what that means is that the variable that you're solving for is going to be under a radical. For instance, on this one we have the 8x plus 1 is under the radical, so we have to get the variable out of the radical. And so if you remember, square roots and squares cancel each other out. So what we can do is, to get this out, we're going to square both sides. So when I square that, I'll have 8x plus 1, and then 5 squared is 25. And then we're just going to solve this like we would a normal equation. Subtract 1. 8x equals 24. Divide by 8, and x equals 3. Now, anytime you have a square root, and you have to check it to make sure that you don't have an extraneous solution. So we're going to do the check and plug it into the original equation. So square root of 8 times 3 plus 1 equals 5. 24 plus 1. Square root of 24 plus 1 is the square root of 25. The square root of 25 is 5. So yes, this is a solution. So the solution is x equals 3. Oops. I'll rewrite that. So I have the square root of 6 minus x equals 3. So again, we're going to square both sides. This gives me 6 minus x equals 9. Subtract 6. Negative x equals 3. Divide by negative 1. So x equals negative 3. We'll check this again. Anytime that you have a square root, you have to check it. So 6 minus a negative 3. Square root of 6 plus 3. And then the square root of 9 is 3. So again, it's yes. So our answer is x equals negative 3. So this one's set up just a little bit differently. The first thing we need to do is to get the radical by itself on one side of the equation. So I'm going to subtract 2. And then we'll square both sides. So 6x plus 4 equals 64. Subtract 4. 6x equals 60, we'll divide by 6. So x equals 10. Again, this was a square root, so we're going to check. So 6 times 10 plus 4 plus 2 equals 10. You always want to plug it back into the original. 8 plus 2 equals 10. So that checks out. That means our solution is x equals 10. So again, we need to get the radical by itself. So I'll subtract 5. And then now we will square both sides. Add 7. So x equals 11 over 2. Since it's a square root, we have to check. 2 times 11 over 2 minus 7. So this is nice. This is the same as 2 over 1, so that's going to cancel out. So 11 minus 7. 11 minus 7 is 4. Square root of 4 is 2. And so this one does not equal. 7 does not equal 3. So for this one, it's no solution. And it doesn't happen a lot, but this is why you have to check anytime there's a perfect square. So this was not a solution. All right. Let's do maybe 2 more. So this one has radicals on both sides. We're still going to do the same thing. We're going to square both sides. Subtract 2x. Add 3. Divide by 2, so x equals 4. Again, these are square roots, so we have to check it. 4 times 4 minus 3 equals 2 times 4 plus 5. So 16 minus 3 is 13. So this is yes. So our answer is x equals 4. All right, let's do one with a cube root. So the cube root of 7x plus 1 equals negative 5. It's going to work the same way. We can cube both sides. Since it's a cube root, we're going to cube both sides. 7x plus 1 equals negative 125. Subtract the 1. So I get a negative 126. So x equals a negative 126 over 7. And when you do cube roots, you do not have to check. It's only when you have the square roots.